October 1962. The North Atlantic is a black, churning void. 200 meters beneath the storm-tossed surface, the attack submarine K-131 glides through the crushing pressure. She is a creature of this void, a sleek, steel predator, the pinnacle of a nation's engineering might. Inside her cramped hull, the air is thick with the smell of recycled oxygen, diesel fumes, and human sweat. The crew moves with the quiet confidence of men who believe they are ghosts. They are the invisible dagger pointed at the heart of their enemy. The captain, a man whose face is a permanent mask of grim determination, stares at the chart table. His boat is one of the new generation, nuclear-powered. It can stay submerged for months, a silent, patient hunter. Their mission is to shadow the American carrier groups, to be the unseen specter that haunts the enemy's dreams. Invisibility is their armor. Silence is their sword. They have trained for years to master the art of disappearing, of melting into the background noise of the ocean. The sonar operator sits hunched in his small, dark station. He is the ears of the submarine. His world is a symphony of clicks, groans, and whistles. He can distinguish the song of a whale from the groan of a distant freighter. He can identify the unique propeller signature of an enemy warship from miles away. He listens to the ocean, and the ocean tells him its secrets. Today, the ocean is quiet, deceptively quiet. Then it happens. A sound that does not belong. It is not the gentle probing of a passive array. It is not the distant rumble of surface traffic. It is a sharp, metallic clang that seems to strike the hull itself. Ping. The sound is brutally intrusive. It is the sound of a searchlight cutting through absolute darkness. The sonar operator flinches, his hands flying to his headset, as if to block a physical blow. Ping. It comes again. Louder. More insistent. A wave of cold dread washes through the control room. Active sonar. But that is impossible. They are deep, running on batteries, their reactor dampened. They are tucked beneath a thermal layer, a shield of cold water that should scatter and distort any sonar beam from the surface. To find them here, an enemy destroyer would have to be almost directly on top of them, and their passive sonar would have heard its approach long ago. Ping. The captain's knuckles are white where he grips the edge of the chart table. Report. His voice is a low growl, a desperate attempt to maintain order in the face of the inexplicable. The sonar operator's voice crackles over the internal comms, laced with a tremor he cannot hide. Active sonar, Comrade Captain. Bearing 090. It's strong. It's perfect, like he's right next to us, but there is nothing on passive sonar. No engine noise. No propeller cavitation. Just the deafening, methodical pinging. Evasive maneuvers. Hard to port. Take her down another 50 meters. The commands are barked out, and the crew responds with practiced efficiency. The deck tilts as the submarine banks and dives, a wounded leviathan trying to shake its pursuer. They are a hawk trying to catch a rat in a burrow, but the hawk seems to know every twist and turn of the tunnel. The pings follow them. They do not waver. They do not fade. With every change of course, every desperate dive, the sound adjusts instantly. Ping. It is a hammer blow of sound, each one a message. We see you. You cannot hide. The room is a tomb. Panic begins to curdle the air. The men exchange wide-eyed glances. The laws of physics as they understand them are being violated. This is not warfare. It is witchcraft. The captain screams into the radio, demanding answers from a silent ocean. The sonar operator stares at his screen, at the clean, sharp spike of the enemy's signal, a symbol of his own professional failure. He is blind, yet the enemy is all-seeing. They are in a sealed room with the lights off, but the enemy is painting them with a laser. They were wrong. They were profoundly, dangerously, and completely wrong. The ocean was not their shield. It was a cage of glass. The report from K-131 lands on a polished desk in the headquarters of the Northern Fleet like a lit fuse. At first, it is dismissed. A nervous captain. A freak atmospheric condition. A new piece of American anti-submarine warfare gear, perhaps, but localized and manageable. The incident is logged, filed, and set aside. But then another report arrives. And another. From the frigid waters of the Greenland-Iceland-UK Gap to the warm currents of the Sargasso Sea, the story is the same. Soviet submarines, the pride of the fleet, are being hunted with impossible ease. A ballistic missile submarine, the nation's ultimate guarantor of security, is on its first patrol in a designated bastion, a deep, remote, and heavily protected sector of the ocean. It is running at whisper-quiet levels, its crew observing strict silence. Suddenly, an American P-3 Orion aircraft appears overhead, as if summoned by a ghost. It drops a pattern of sonobuoys in a perfect circle around the submarine and begins its attack run. The submarine is forced to break off its patrol and flee. It was never in danger of being sunk, not in peacetime. It was in danger of something far worse, being rendered irrelevant. The trickle of reports becomes a flood. The anecdotes coalesce into a terrifying pattern. What was once a tactical problem is now a full-blown strategic emergency. The high command convenes in windowless, smoke-filled rooms. Maps are unrolled. Charts are analyzed. The faces of admirals, men who have dedicated their lives to the sea, are etched with a mixture of fury and fear. Their entire naval doctrine, the very foundation of their strategy, is built on a single, inviolable premise: the opacity of the ocean. Their nuclear deterrent relies on the ability of their missile submarines to disappear, to become undetectable, ensuring a devastating second strike in the event of war. This new American capability does not just threaten a few boats. It invalidates the entire doctrine. It rips the heart out of their strategic posture. The bastions are no longer fortresses, they are shooting galleries. The silent hunters have become cornered prey. The carefully constructed balance of terror, the grim calculus that has kept the world from nuclear annihilation, has been shattered. The enemy now holds a trump card of unimaginable power. How do you fight an enemy you cannot see, but who can see your every move? The geopolitical implications are catastrophic. The nation's standing as a global superpower is predicated on its military might, and a huge part of that might is now revealed to be a hollow shell. The billions of rubles invested in building the world's most advanced submarine fleet appear to have been wasted. The industrial base, already straining under the demands of the arms race, is faced with an adversary who seems to have made a generational leap in technology overnight. It is a national humiliation, a wound to their scientific pride and their martial ego. On the front lines, in the claustrophobic steel tubes gliding beneath the waves, the psychological deterioration is swift and severe. Fear spreads like a contagion. The confident swagger of the submariners is replaced by a gnawing paranoia. Crews begin to hear phantom noises, the ghosts of sonar pings in the static. Captains, once aggressive and daring, become timid. They hug the noisy coastal shelves, hiding among freighters like frightened minnows. They dare not venture into the deep ocean, the place that was once their sanctuary. A mythology is born in the hushed conversations of the mess halls and torpedo rooms. They give the phenomenon a name. They call it the zone, or sometimes, the whispering sea. They speak of it in low tones, as if saying its name too loudly might attract its attention. The zone is a place on the charts where you simply do not go. The whispering sea is an ocean that is turned against them, that has become an extension of the enemy's will. Morale plummets. The ocean is no longer a vast, protective wilderness. It is a haunted house, and they are trapped inside. The panic in the fleet forces the hand of the Politburo. The situation is untenable. A special commission is formed, drawing together the finest minds in the nation. It is a desperate assembly of naval architects, intelligence officers from the GRU, acoustical physicists, and party officials whose job is to ensure the right conclusions are reached. They are given a blank check and absolute authority. Their mission is simple and impossible: to identify and neutralize the American advantage. The project is given a code name that reflects the scale of the monster they are hunting: Project Leviathan. The investigation begins. Teams are scrambled to debrief every single submarine captain who has been hunted by the phantom sonar. They are placed in sterile rooms and questioned for hours, their patrol logs dissected line by line. The interrogators are looking for a pattern, a common thread. Did they cross a certain latitude? Were they at a specific depth? Did they perform a particular maneuver? The captains are exhausted and terrified. Their accounts are filled with the frantic energy of men who have witnessed something that defies rational explanation. It refused to die, one captain says, his voice hollow. It was everywhere at once. Other teams are dispatched to the gray, windswept naval yards where the submarines are refitted. They crawl through the hulls, checking every weld, every piece of machinery. The initial assumption is that the problem must be their own, a flaw in the design, a noisy pump that only activates at certain depths, a harmonic vibration that telegraphs their position. They wrap machinery in sound-dampening foam. They redesign propeller blades. They are looking for a mechanical culprit, a tangible error they can fix. Intelligence assets are activated across the globe. Spies are tasked with finding any scrap of information about new American anti-submarine programs. Specially equipped fishing trawlers, bristling with antennas and hydrophones, are sent to loiter off the coasts of American naval bases, hoping to overhear a stray radio transmission or intercept a new type of signal. They trail American warships, trying to get close enough to analyze their sonar emissions. They are hunters trying to understand a new predator by studying its tracks, but the tracks are invisible. The evidence that flows back to Project Leviathan's headquarters only deepens the mystery. It is a mass of contradictions. One submarine is detected in the crushing depths of an oceanic trench, a place where sound should be trapped and muffled. Another is found in the cacophony of a busy shipping lane, where its signature should have been lost in the noise. A third is tracked through a violent storm, its own sensors blinded by the sound of the waves, yet the Americans follow its every move. There is no consistent depth, no consistent speed, no consistent location. The phenomenon is maddeningly universal. The sensor data is even more confusing. The recordings from the submarine's passive sonar arrays show nothing. The water is clear of engine noise right up until the moment the first active ping strikes the hull. There are no precursor signals. No reconnaissance aircraft detected on radar. The American destroyers and planes seem to materialize out of the ether, already knowing the submarine's precise location. It is as if they are being guided by an invisible hand. The collected data does not solve the mystery. It makes the phenomenon seem even more impossible, more supernatural. The Commission is drowning in facts that point to no logical conclusion. They are chasing a ghost. The analysts of Project Leviathan are trapped. They are brilliant men, but their brilliance is constrained by their worldview. They are products of a system that thinks in terms of material production, more steel, bigger engines, more powerful warheads. Their entire military philosophy is based on tangible assets. Therefore, the American advantage must also be a tangible asset, a new weapon, a magic bullet. They are incapable of conceiving that the advantage might not be a thing at all, but a system, a different way of thinking. This fundamental misunderstanding, this failure of imagination, sends them down a series of intellectual rabbit holes. They begin to formulate theories, trying to fit the impossible data into their existing framework. Each theory is more desperate than the last. They are searching for the phantom in their own minds, projecting their own industrial logic onto their adversary. Their investigation is no longer a search for the truth. It is a search for an explanation they can comprehend. The first and most persistent theory is that of a super sonar. The engineers propose that the Americans have developed a new type of active sonar with unimaginable power and range. They sketch out designs for massive transducers, speculating that the sonar beams are being bounced off the ionosphere or the sea floor, allowing them to survey an entire ocean basin from a single ship. It is a brute force solution, the kind they would have designed themselves. It is elegant in its simplicity, and it is completely wrong. It would require a power source the size of a city and generate so much noise it would announce its presence to every submarine in the hemisphere. The second theory emerges from the Intelligence Directorate. They focus on the fact that submarines are large metal objects. They propose that the Americans have deployed a constellation of satellites equipped with hypersensitive magnetic anomaly detectors, or MAD. These satellites, they argue, can detect the minute distortions in the Earth's magnetic field caused by a submerged submarine's hull. This theory explains the lack of acoustic warning. It explains the ability to detect subs anywhere. It is a technologically plausible idea, but the energy required to detect such a tiny anomaly from orbit is astronomical. The theory is a fiction. As the mystery deepens, the theories grow more exotic. A group of physicists, desperate for an answer, proposes neutrino detection. A submarine's nuclear reactor, they argue, is a powerful source of neutrinos. If the Americans have found a way to detect these ghost-like particles, they could track every nuclear submarine in the world. It is a concept lifted directly from science fiction. It would require a detector the size of a mountain and would violate several known principles of physics. Yet, in the atmosphere of paranoia and confusion, it is considered seriously. The GRU, not to be outdone, contributes its own brand of creative paranoia. One report, citing a dubious source, suggests the American Navy has weaponized marine life. They claim the Americans have trained dolphins and sea lions, fitting them with compact sonar devices and teaching them to hunt for Soviet submarines. The image is absurd, an army of aquatic mammals policing the seas, but it is a testament to the level of desperation. They would rather believe the enemy has allied itself with animals than confront the terrifying possibility of a systemic technological gap. A fifth theory revolves around ultra-long-wave radio signals, the kind used to communicate with submerged submarines. Perhaps, the communications experts suggest, the Americans are using these powerful transmissions in a new way, bouncing them off submarines and reading the reflections, a kind of subterranean radar. Another group becomes convinced the ocean is seeded with millions of tiny, autonomous acoustic mines that lie dormant on the seabed until a submarine passes overhead, at which point they send a signal to a central command post. They are imagining a network, but a crude, mechanical one. A network of things, not a network of information. Based on these flawed theories, the High Command issues a series of disastrous new orders. These are the futile countermeasures of a blind man swatting at a fly he can only hear. To combat the imagined super sonar, submarines are coated with new anechoic tiles, a rubbery material designed to absorb sound waves. The adhesive is faulty, and the tiles peel off at deep pressures, creating hydrodynamic noise and making the submarines easier to detect. To counter the non-existent MAD satellites, engineers install massive, power-hungry degaussing coils inside the submarines. These systems generate their own distinct acoustic and electronic signatures, adding yet another layer of noise for the enemy to hear. Captains are ordered to perform complex, erratic maneuvers, crazy Ivans, to try and shake off any potential trackers. These maneuvers burn precious fuel and create loud hydraulic transients, effectively ringing a dinner bell for anyone listening. Each countermeasure, born of a wrong conclusion, makes the situation worse. They are not fighting the enemy. They are fighting a phantom of their own creation, and they are losing badly. While the admirals in the Northern Fleet were staring at maps and inventing phantom technologies, the answer to their mystery was being quietly processed in a series of climate-controlled, windowless buildings on the American coast. There were no frantic commands here. No panic. There was only the low hum of cooling fans, the smell of coffee, and the steady, rhythmic clicking of magnetic tape reels. Men in short-sleeved shirts and ties watched green lines flicker across oscilloscopes and sheets of paper scroll out of spectrographs, covered in what looked like seismic readings. They were not sailors or warriors. They were acousticians, mathematicians, and engineers. And they were listening to the ocean. The program's origin was not in a weapons laboratory, but in academia. In the years after the Second World War, oceanographers studying the transmission of sound in water made a remarkable discovery. They found a specific layer in the deep ocean, a deep sound channel, where temperature and pressure conditions created a perfect conduit for sound waves. Sound caught in this channel could travel for thousands of miles with astonishingly little loss of energy. An explosion off the coast of Australia could be clearly heard by sensors off the coast of Bermuda. The ocean, it turned out, had its own natural fiber optic network. A few visionary naval officers and scientists saw the military potential. What if, instead of chasing submarines with destroyers, you simply listened for them? What if you could turn the entire ocean basin into a giant listening device? The idea was audacious. It required a philosophical shift. The problem was not to build a better, louder sonar to shout into the depths. The problem was to build a better ear to listen to the ocean's whispers. The project was born. It was a massive undertaking, executed over more than a decade in near-total secrecy. It was a triumph of systems engineering, a testament to a different way of waging war. The core innovation was not a single piece of hardware. It was a distributed, integrated system. The first component was the network of sensors. Thousands of hydrophones, marvels of acoustic sensitivity, were laid in vast arrays on the deep ocean floor. They were placed at precise locations to take advantage of the deep sound channel. These arrays were connected by thousands of miles of armored undersea cable, another technological feat in itself, which carried the faint acoustic signals back to shore stations. It was a continent-spanning web, an invisible nervous system laid across the bottom of the sea. The second component was the computational advantage. At the shore stations, the raw data from the hydrophones was fed into powerful digital computers. This was the system's brain. The computers ran complex algorithms that filtered out the background noise of the ocean, the storms, the marine life, the commercial shipping, and search for the specific, faint signatures of submarine machinery. By correlating the arrival times of a single sound at multiple, widely spaced arrays, the computers could triangulate its source with incredible precision. They could locate a submarine hundreds, even thousands, of miles away. The system did not track the submarine itself. It tracked the submarine's sound as it propagated through the ocean's deep channel. Finally, there was the engineering philosophy. It was a patient, scientific, long-term approach. The Navy had spent years meticulously mapping the ocean floor and studying the acoustic properties of seawater in different regions and seasons. They understood the environment they were operating in better than anyone in the world. They had brought a computer to a knife fight. Their system was built on a foundation of deep scientific understanding, not just brute industrial might. It was a system that prioritized information dominance over kinetic force. This system, this vast, silent network, effortlessly produced the impossible effects that were terrorizing the Soviet submarine fleet. When a Soviet submarine left its pen in the Arctic, the sound of its powerful pumps and turbines, no matter how quiet the crew tried to be, entered the water. That sound energy, a faint whisper against the roar of the sea, propagated through the deep sound channel. Hundreds of miles away, the hydrophone arrays picked it up. The signal was a ghost, a shadow of a sound, but it was there. The computers on shore analyzed the signal, identified its unique signature, and calculated a position. This initial position, perhaps accurate to within a 50-mile square, was the first piece of the puzzle. That data was then relayed to an anti-submarine warfare command center. A long-range patrol aircraft or a hunter-killer submarine would be dispatched to the designated area. Only then, once they were in the immediate vicinity, would these assets use their own local, tactical sonar, active and passive, to pinpoint the target. The Soviet submarine crew experienced only this final, terrifying stage. The destroyer that appeared out of nowhere. The aircraft that dropped sonobuoys in a perfect ring. They saw the tip of the spear, but they were completely unaware of the vast intelligence network that had guided its flight across an entire ocean. They were fighting a network they couldn't see, a system they couldn't even imagine. For years, the Soviet high command stumbled in the dark, haunted by the specter of American technological superiority. They were paralyzed by their own wrong conclusions. The breakthrough, when it finally came, did not come from a brilliant piece of engineering analysis or a daring intelligence raid. It came from a place they least expected, the mundane, grubby world of human betrayal. It came in the form of a disgruntled American naval communications officer, a man with access to the highest levels of classified information and a desperate need for cash. Through a series of dead drops and clandestine meetings in foreign capitals, a torrent of classified documents began to flow from this traitor into the hands of the GRU. At first, the Soviets were incredulous. The documents described a system so vast, so ambitious, so far beyond their own capabilities that it seemed like deliberate disinformation. They described a program to wire the entire North Atlantic seabed. They contained technical manuals for signal processing computers that were a generation ahead of their own. They included maps, marked with the precise locations of the undersea cable routes and the listening arrays. The undeniable proof came in the form of daily and weekly intelligence summaries. These summaries, intended for top American admirals, listed the current positions and predicted tracks of specific Soviet ballistic missile submarines. The Soviets cross-referenced these reports with their own highly classified patrol logs. The data matched perfectly. The Americans hadn't just been lucky. They hadn't been using some exotic new weapon. They had been watching and listening the entire time. They knew. They had always known. The final report from Project Leviathan, incorporating the intelligence from the American trader, was delivered to the Soviet Naval Command in a lead-line briefcase. The admirals gathered in a secure vault, the air thick with tension. As the intelligence officer read the findings, a chilling silence descended upon the room. The initial reaction was not anger, but a profound, sickening shock. It was the shock of a chess player who, after moving his pieces with great care, suddenly realizes his opponent has been watching from above, seeing the entire board, and has known his every move from the very beginning. The layers of shock were deep and devastating. First came the technological shock. "They have wired the ocean floor?" one admiral whispered, the words catching in his throat. It was a concept so audacious it bordered on science fiction. The sheer scale of the engineering, thousands of miles of cable laid in the crushing depths of the abyss, arrays of sensors that could hear a pin drop 1,000 miles away, was almost impossible to comprehend. They had been building submarines. The Americans had been building a synthetic god of the sea. Then came the industrial shock. As the details of the system's components were laid out, the precision manufacturing of the hydrophones, the advanced microelectronics of the computers, the specialized cable-laying ships, a grim realization dawned. They couldn't build this. Their centralized command economy, so effective at churning out massive quantities of tanks and artillery, lacked the finesse, the quality control, and the computational expertise to create such a sophisticated, integrated system. The project would be too complex, too expensive, and its secrets impossible to keep within their leaky bureaucracy. The Americans hadn't just built a better machine. They had built it with a better industrial base. The final layer of shock was the most humiliating. It was philosophical. All this time, they had been focused on the wrong problem. They had poured their best minds and vast resources into making their submarines quieter, into perfecting the art of hiding. It was a tactical problem. The Americans, meanwhile, had solved the strategic problem: how to make the entire ocean transparent. They had fundamentally outthought them. The realization that their entire strategic approach to undersea warfare had been flawed from its inception was a professional wound from which they would never fully recover. The room was a tomb, filled with the ghosts of their own dead assumptions. An order, born of desperation and wounded pride, came down from the highest levels of the state. Copy it. Screw for screw. The Soviet Union, a superpower defined by its ability to replicate and mass-produce military hardware, embarked on its own massive program to create a similar system. They called it Harmony. It was to be their answer to the American network, a visible symbol that they had closed the technological gap. But the attempt was a tragic failure, a perfect illustration of the systemic flaws that plagued their society. They could copy the hardware, but they could not copy the philosophy behind it. They lacked the specialized ships needed to lay cables quietly and precisely in the deep ocean. Their attempts were crude and easily detected by the very American network they sought to emulate. They lacked the advanced signal processing capabilities. Their computers were large, power-hungry machines that struggled to filter the faint submarine signatures from the ocean's cacophony. Their hydrophones were less sensitive, their cables noisier. They copied the form of the American system, but missed its essence. It was like trying to build a modern supercar using the tools and techniques of a 1950s tractor factory. The attempt to reverse-engineer the technology was a dismal failure because it was never just about the technology. It was about the ecosystem that produced it. It required a level of scientific collaboration, industrial precision, and computational expertise that their rigid, top-down system could not foster. The Harmony system was eventually deployed in limited areas, primarily to protect their own naval bases in the Barents Sea. It was a pale, flawed imitation, a monument to their own inability to innovate, proving only how far behind they truly were. The final scorecard of this silent, decades-long conflict was brutally lopsided. For nearly 20 years, the crown jewels of the Soviet nuclear deterrent, their fleet of ballistic missile submarines, had been operating under a complete illusion of safety. Every patrol, every secret mission, every supposedly secure bastion had been transparent to their adversary. The strategic balance of the Cold War, which they believed rested on their assured second strike capability, had been a sham. The Americans had held a winning hand but had wisely never shown it, allowing their opponent to continue betting on a bluff. The cost was not measured in sunken ships, but in wasted decades and squandered billions of rubles. This hidden technological disparity was a critical, if unseen, engine of history. It forced the Soviets into an ever more expensive arms race. In a desperate attempt to regain their invisibility, they poured immense resources into developing new, quieter submarines. The Akula class, the Sierra class, these were masterpieces of engineering, designed with the single purpose of evading a listening network whose full capabilities they still did not fully grasp. This relentless, asymmetric spending placed an unbearable strain on an already struggling Soviet economy. The effort to silence their submarines was a direct contributor to the economic decay that would ultimately lead to the collapse of the Soviet Union. The microchip, processing faint sounds in a quiet room on shore, had defeated the smokestack, forging steel for a fleet that could never truly hide. The failure was not tactical or industrial. It was systemic. It was the deep, unbridgeable chasm between two competing philosophies. One system, centralized and paranoid, believed in brute force. It sought to solve problems by building bigger, faster, more powerful things. It could imitate, but it could not innovate in the same way. The other system, decentralized and collaborative, empowered its scientists and engineers. It fostered a culture of long-term research and intellectual curiosity. It sought to solve problems not with force, but with information. It was the ultimate triumph of information dominance over industrial might. The legacy of this silent technological victory shaped the future of warfare. It proved that the decisive battleground of the future would not be on the land or the sea, but in the electromagnetic spectrum and the silicon of microprocessors. The network that had rendered the ocean transparent was the forerunner of the networked, data-driven military of the 21st century. It taught a lesson that would be learned again and again. The most powerful weapon is not the one that makes the loudest bang, but the one that provides the clearest picture. It was the dawn of a new age, where seeing the enemy was more important than destroying them. The Cold War was a contest of ideologies, economies, and armies. But it was also a war of systems, of competing methods for understanding and manipulating the world. One system sought to conquer the ocean by force, to hide in its vast, dark spaces. The other sought to understand the ocean, to learn its secrets, to listen to its subtle rhythms. And in doing so, it turned the ocean itself into an inescapable instrument of surveillance. The faint whispers carried by the deep sound channel were more than just the noise of propellers and pumps. They were the sound of an empire's strategic foundation cracking, one lonely, hunted submarine at a time.